Now, this is workshop week 8, exchange rate models. And as I said, all of these documents, this document here, and the stata files for the workshop are all on the Blackboard sites of the modules. This is workshop week 8, exchange rate models. Objectives: to learn to convert variables using exchange rates, to use price data to assess whether currency is overvalued, to understand the concepts of law of one price and purchasing power parity, to test these hypotheses, to learn to work with panel data, to test exchange rate theories using panel data models. So there's quite a lot here. We're speeding up because, you know, this is week 8. You've done your take-home assignment. You've got a lot of practice with the take-home assignment. You've got the feedback to the take-home assignment. I hope you were all at the lectures this week, because the first lecture this week was on exchange rate models, the first hour. The second hour, I was giving you feedback on the take-home assignment. In other words, I was giving you the answer to the take-home assignment. So if you weren't there, then have a look at the recording. That's important. I told you that the take-home assignment is similar in many ways to the other assessment that you're going to have, which is the computer test, which you'll have in January. The questions on that test are similar in style to the questions that you answered in the take-home assignment. So keep working on the take-home assignment. Use it in your revision. I've given you the answers to it. Okay, the first hour of the lecture was exchange rate models. And this workshop is following up on that lecture. We've got a data set called Big Mac 21. It contains panel data on the following variables for 43 countries observed between 2011 and 2021. Country ID, currency code, year, price of Big Mac in USA, exchange rate, GDP and GDP in USA. Now, it's panel data because we have a cross section of 43 countries, each of which is observed every year. So we're observing 43 countries again and again, right? That's why it's called panel data. It's a cross section of countries. So in a sense, it's cross section data, but it's also time series data because we're observing each country repeatedly every year. So there's a cross-section dimension to the data and there's a time series dimension, and that's what we mean by panel data. And panel data calls for a different set of models to the ones that we've been using. We've been using linear regression. We've been using the regress command. If you have panel data, and a lot of you are going to need panel data models when you do your dissertations, because a surprising number of students use panel data in their dissertations because they have a sample of countries and they have data over time for each country, similar to what we have here. So it's useful for you to know what panel data means and how to estimate a panel data model. That's something we touch on in this workshop. The stata commands necessary for answering this exercise are contained in the do file, Big Mac do file. And the questions are, first of all, we divide the local price by the exchange rate. Obviously, we've got the local price in the local currency for each country. We can't compare them because, you know, the currencies are very different. So we divide by the exchange rate so that we have the price in US dollars of a Big Mac in each country, and then we can compare them. And we can ask questions like this: in a particular year, which currency is the most overvalued and which is the most undervalued? Well, let's just go to the exercise. And by the way, the answers to this exercise are contained in the lecture that I gave on Monday. All right, on Monday I gave this lecture and the lecture notes are on the Blackboard site. I started off with some data on exchange rates and a graph, and then I got into talking about the Big Mac index, and I showed you some data. I sorted the data and showed you it again. And then I told you about this model, and then I gave you some results. Well, the results that you see here in this document, this lecture notes document, are the ones that we are obtaining in the workshop. So if you want a handout containing the answer to the workshop, this is it. It's in the lecture. Okay, so I'm going to go to Stata, and here's the do file. So if you all know how to do this, you've done this lots of times. You have to copy the data set and the do file to a particular location. Then you have to use the command cd to change directory, to move to the location in which the Stata files are located. You see, and having done that, having gone cd to the location, then this command should work. But that command doesn't work because it needs an option, doesn't it? When you use the command use data set, you need the option clear. It has to clear whatever was in memory before. So this command should work, and yes, it does. Okay, use Big Mac _ 2021. And the reason why this command works is because I've just changed to the directory. I've just told Stata where to look for files, and Stata is looking for files in the folder in which this data set is located. And the variables in the data set are, I'm just going to change the font. The variables in the data set are country ID, year, currency, as listed in the question. Let's have a look at the data. If you go list, oh, that's no good. I'll try with font 12. No. Okay, the easiest way of looking at the data is to go to data browser. Data editor browser, which is up here. And here we see an alphabetical listing of countries: Argentina, Australia, Brazil, Britain, Canada. And this is 2011. So this is the first year of the data. 2011 was the first year. There are 11 years in total, 2011 to 2021 inclusive. And we see the name of the currency, and we see the currency code as well. Currency code may be useful. And then we have, let's make this bigger, there. Then we have P local. P local is the price in local currency of the Big Mac. The Big Mac, the McDonald's hamburger. I explained in the lectures how this measure of currency valuation has taken off. The Economist introduced the Big Mac index in 1986. In the time since, the Big Mac index has become more and more popular as a way of judging whether a currency is overvalued or undervalued. So here we have the local price of a Big Mac. So in 2011, in Argentina, you could get a Big Mac for 20 Argentinian pesos. And in 2011, the price of a Big Mac in the USA was $4. Now, we need that. You see, that's the same everywhere, obviously, because it's the price in the USA. That's the same in every country. but it changes in different years. And then we have the exchange rate. So in 2011, you could get 4.13 Argentinian pesos for $1. That's the exchange rate to the US dollar. And then we have information on GDP in the countries. This is GDP per head, obviously, so that we can compare between countries. Right, so that's 2011, and you can see it's panel data because we've got lots of observations for each year. And the last year is 2021 here. So, let's go to the do file. There's a do file containing all the commands that we need to answer the questions in the workshop. This is the do file. It's called Big Mac _ do file. And it starts off with the command, well, set more off. That just means that if you can run the whole thing and it will run uninterrupted. I'm just waiting for it to run. This graph takes a while. I'll come back to this graph in a minute. Now, what I just did was I pressed that button and that executes the whole do file. The whole do file runs if you press that without highlighting anything. If you don't highlight anything, then the whole file runs. And set more off just means it runs without prompting you to continue with the output. Anyway, this command here reads the data, and then this command here lists the data for the year 2021. So I'm going to, well, we only need this command, don't we? Command 10. So I'm going to highlight line 10 and run line 10. And then we get this table, which is the data in 2021. That's the data in the current year. And by the way, this is real data. Often in these workshops, I give you data sets, which is made up data. Well, there's nothing wrong with that, but this data is real data. And 2021, we have each country, the currency, the local price, and the exchange rate. And obviously there's problems in Venezuela at the moment, and that's why the Venezuelan price of a Big Mac is 3.0 times 10 to the plus 7. I hope everyone knows what that means. That means 30 million Bolivar. A Big Mac costs 30 million Bolivar in Venezuela. What's the exchange rate? The exchange rate of the Venezuelan Bolivar is 3.6 million Bolivar to the US dollar. Anyway, we can't compare these numbers. We want to be able to say in which country is the Big Mac price the highest, in which country is the lowest. But obviously, I hope you can see that we can't compare these numbers because these numbers are in local currency. What do we need to do to make the prices comparable? We need to divide by the exchange rate. That's all we need to do. We need to divide each price by the exchange rate, and then we have the price in US dollars of a Big Mac in each country. And then we can compare them and we can ask which is lowest and which is highest. So let's go back to the do file. That's what we're doing here. In line 14, we're going generate P local dollar. P local was the price in local currency. P local dollar is the local price in US dollars. And that's P local divided by exchange rate. And then if we want, we can generate this thing overval, which is just a measure of overvaluation. All I'm doing there is that I'm dividing the price in dollars by the price in the USA. So that'll just give us a fraction, which is greater than 1 if the Big Mac price is higher than the price in the USA, price of a Big Mac in the USA, and lower than 1 if it's the price is lower than the price in the USA. So that's like an index of overvaluation. It's not too useful. And then what I'm doing here is I'm sorting the data. I told you all how to sort data in the take-home assignment. You had to sort by the residual. Well, here we're sorting by 2 things. We're sorting first by year and then by overvaluation. Or overvaluation is basically the same as this variable here, P local dollar. So if we want, we could sort by P local dollar. And then I'm sorting, so I'm sorting by this variable here essentially, and then I'm listing the data again. Notice that with the list command, at the end we have if year equals 2021. That's what gives us just part of the data set. It just gives us the part that is for the current year. Okay, so I'm going to go from line 1 to line 23. I'm going to do that again because we want to be able to see it. That's better. I just changed the font so that we could see this table. This table is the result of line 23. We're listing all the variables in the year 2021, and we've sorted by the overvaluation variable. So we're going to get an ordered list of countries from the lowest Big Mac price to the highest Big Mac price. That's what we've got in this table. This table appears in the lecture notes. So what we have is an ordered list. The first in the list is the one with the lowest Big Mac price. P local dollar, that's this variable here, P local dollar. We can't see the whole name there because it's too long. That's P local dollar. The price of a Big Mac in Russia is $2, $2 US dollars, 2.26 US dollars. And that's the lowest price. The second lowest is South Africa, 2.28 US dollars. Remember, this is converted into US dollars, and that's why we're able to compare. Turkey, Indonesia, Malaysia, Ukraine, India, Taiwan. Now, a lot of the countries at this end of the list are developing countries, a lot, but not all. And likewise, a lot of the countries at the other end of the list are developed countries. That's because prices tend to be higher in developed countries than in developing countries. Now we come back to that at the end. That's one important reason why the law of one price does not hold. But yes, we come back to that at the end. Now remember what the law of one price is. The law of one price is that the price of a Big Mac should be the same in all countries. So P local dollar, this variable here, according to the law of one price, it should be the same everywhere. Now we can see that it isn't. It varies from 2.26 to 8.34. So there's huge variation in the price of this good. Now, of course, the law of one price, the theory, only applies to goods that are tradable. I told you this in the lecture. Is the Big Mac tradable? Can you buy a Big Mac in one country, take it to another country and sell it? Not really. No, well, you could do, but not really. But think of it like this. The ingredients of a Big Mac, whatever they are, there are probably a lot, but the ingredients are tradable. So if the ingredients of the Big Mac are tradable, then the Big Mac itself is It's not tradable, but it's not completely untradable. We can think of a spectrum of tradability, and the Big Mac is somewhere in that spectrum. Some goods are completely untradable. For example, the standard example is haircuts. You definitely cannot buy a haircut in one country and sell it in another country. So haircuts, services such as haircuts are not tradable. So things like the law of one price and purchasing power parity only apply to goods that are tradable or at least partially tradable. So, I mean, that's one reason why the price isn't the same in all countries. What are we doing next? Yeah. Here's a really useful thing. When you have panel data, how do you present it? Obviously, when you have time series data, you want to do a time series graph. That is a graph of the variable over time. If you have cross-section data, you probably want to do a scatter plot of one variable against another. What if you have panel data? It's awkward. How do you plot the data? I'll show you. Now, this is something you'll get used to when you work with panel data. All the panel data commands start with xt, right? So we know the command line. The command line is for a line graph. Xt line is the panel version of that command. Let's just do this. Now, whenever you use xt commands, panel commands, the first command you need is this one here, which is xt set the cross-section variable, which is country ID, and the time series variable, which is year. What happens when you do that variable? Well, when that command, you're telling Stata that it's panel data, and you're telling Stata that the panel variable is country ID, and that the time variable is year, and the time variable goes from 2011 to 2021. Having done that command, you can do this command, which is xt line. And we're doing a line graph of P local dollar. So we're doing a line graph of the price of a Big Mac in dollars in each country. And look what you get. You get not one time series graph, but a lot of time series graphs, one for each country. Can you see this graph at home? People who are at home, can you see this graph? Are you saying yes? Yes. Okay, thanks. This is the graph. Okay, panel data. You know, we've got lots of countries, and for each country, we have time. Now, the time axis is only on here, 2011 to 2021. You can see the time axis here. You don't need to see it on all these, and you can see the vertical axis is the Big Mac price in US dollars. What does this graph tell us? Well, it tells us that in some countries you seem to have mild inflation. Yeah, in some countries the price is going up slightly. In some countries it appears to be going down. In some countries it's highly volatile. Well, in at least one country it's highly volatile. But of course, this is not just price inflation. It's to do with what's happening to the exchange rate as well, because remember what this is. This is the price divided by the exchange rate. So, I mean, the reason I'm showing you this is if you ever work with panel data, this is the best way of presenting the panel data using the xt line command. Okay, now if we just go back to the exercise, what are we doing next? We're considering this regression model. We're considering log of local price over price in USA. That's the dependent variable, and the explanatory variable is log of the exchange rate. Now, as explained in the lecture notes, if the law of one price holds, then this ratio, P local over P USA, should be equal to the exchange rate. If the law of one price holds. If prices are the same in every country, then it's because the exchange rate is correct in inverted commas. If the law of one price holds, it means the ratio of prices equals the exchange rate. So we can do a regression and we can test the law of one price, because we're doing a regression of this variable on this variable with an intercept and a slope. The hypothesis that we want to test is that the intercept equals 0 and the slope equals 1. Can everyone see that? If the intercept in this regression is 0 and the slope equals 1, then essentially we're saying that the left-hand side variable equals the right-hand side variable, which is exactly the hypothesis that we're interested in, which is the law of one price. So that's why part C of the question we have test the hypothesis beta 1 equals 0, beta 2 equals 1, and that's the law of one price. Now, also, as explained in the lecture, there's a weaker version of the law of one price, which we call purchasing power parity, or we can call it, to make it unambiguous, we can call it relative purchasing power parity. And what that is it's purchasing power parity is just saying that when the price level changes in one country but not in another, then the exchange rate adjusts to compensate. That's all, and that's much more believable than the law of one price, isn't it? I don't think anyone really believes that prices should be the same everywhere, but we could believe in purchasing power parity. That is, we could believe that when prices adjust, relative prices between two countries, when they adjust, then the exchange rate adjusts to compensate. We could believe that. And how do you test that hypothesis? All you're testing there is that the slope in this regression equals 1. You're not testing anything about the intercept. So it's a weaker hypothesis. We're just interested in whether beta 2 equals 1. We're not testing beta 1. That's the test of PPP, and that's part D of the question. Okay, let's see what happens when we do that. I'm going to go back to Stata, the do file. Here we're generating the ratio of local Big Mac price to Big Mac price in USA. That's to get the variable that's on the left-hand side. Generate that ratio, and then you take the log of it. You know, we've seen double log models before. It's very useful in econometrics to take logs of variables and then do regressions using the logs. And that's what we're doing here. We're using the log of this ratio on the left, and we're using the log of the exchange rate on the right. Remember that log, you could use the log command here or the ln command. They're the same. Ln just means natural log. Okay, log is the same command, is the same function. So that's the dependent variable, log p ratio. That's the explanatory variable, log e, log exchange rate. And then we do a regression of log p ratio on log e. There. Oh dear. There, and then we get an intercept Remember, we're interested in whether the intercept's 0 and the slope's 1. Well, the slope doesn't look too far from 1, does it? I think I'm going to increase the font size again. 12. No. The slope does not look too far from 1, 0.954. However, it is far from 1 because you can look at the confidence interval, can't you? 0.94 to 0.97. If the confidence interval is nowhere near, well, it's not too far away from 1, but it does not include 1. So that's a bit like rejecting the hypothesis that the slope is 1. So it's not too far from 1. It's not too far from 1. It's significantly different from 1. The intercept is significantly different from 0. That's what we're interested in. How do we know that? Because of this t-test here and this p-value. Remember, don't look at this t-test and this p-value. This t-test and this p-value tell you that that is significantly different from 0. That's not what we're testing. We're testing that that equals 0 and that equals 1. Remember? So we can do an f-test of that. The next command in the do file is an f-test of the joint hypothesis that the intercept equals 0 and the slope equals 1. And this is a test of the law of one price. See, test intercept equals 0, slope equals 1. It's an f-test, 2 restrictions. So the first degree of freedom is 2. Second degree of freedom is n minus k. Well, n is clearly 260 something. Oh, sorry, 464. N is 464. K in this model is 2. So this is the f-test. Big value, p-value equals 0. We're rejecting the law of one price. Well, we knew the law of one price does not hold because we compared the prices and they were all different. So that's not a surprising result. And then to test PPP, we're just testing that the slope equals 1. That number equals, well, I just talked about the confidence interval and I said it looks like it's not 1. Well, we can confirm that. This is a test of the hypothesis that the slope equals 1. And this is an f-test, but there's only one restriction being tested. There's the test statistic, there's the p-value. It's an f-test. Now, you could do a t-test of that. How would you do a t-test? If you wanted to do a t-test, you could. You would go the estimate minus 1. Estimate 0.95 minus 1, because that's what we're testing it against. That's the value under the null hypothesis, divided by the standard error. You see, usually you're testing whether something's 0. So usually you're going estimate divided by standard error and you get the t ratio. Here we're testing, is this thing 1? So we could go 0.95 minus 1 divided by the standard error, and that would give us a t statistic, and we could compare that to t tables. But the f statistic that we've just done is equivalent to that t statistic. This f statistic is the square of that the t statistic. If you did a t-test, the f statistic that you see here is the square of that t statistic. So they're equivalent tests. And we're rejecting purchasing power parity as well. That's the conclusion. Anyway, what we've just done is we've used the regress command. We used the regress command, which is essentially a pooled regression. We're just treating these 464 observations all on the same basis. We are not allowing for the fact that the 464 observations are divided into different groups. or clusters, which are the countries. Okay, and that's where we get into panel data modeling. If there are any differences between countries, we need to allow for those differences. Now, let's go back to the do file again. What we can do, one way of allowing for the differences between countries is to include country dummies. Now, you know how to do this because the things we've done already are a bit like this, especially in the take-home assignment. Look what we're doing here. We're doing the same regression again. This is line 55 of the do file. We're doing the same regression again, log of P ratio on log of exchange rate with a set of country dummies, I.country ID. How many countries are there? 43. So what's going to happen here, we're going to add 42 dummy variables to the regression to allow for differences between countries. And then we're going to test purchasing power parity again. Let's give up on the law of one price. We know the law of one price doesn't hold, but let's persist with purchasing power parity. Okay, what happens when we do this? Excuse me. Okay, well, as expected, we've got lots of dummy variables because we just use I.country ID. Hello, did someone want to say something? Can you see what I'm doing? The people at home, can you see what I'm doing? Better check again. No. Yes? Okay, I'll carry on. Right. We've got 464 observations. We're doing the same regression again, but with a set of 42 dummy variables. Remember, there's a base case. The first one on the list will be the base case. So that will be Argentina, won't it? That's why we don't see Argentina in the regression, because that's the base case. And then we're basically allowing an intercept shift, depending on which country we're in. Now, these numbers here don't actually tell us anything important, because the reason why the countries are different is partly because currencies have different nominal values. Okay. One of the highest numbers you see in this table is Indonesia, 0.24, Colombia, 0.55. And the reason why those numbers are high is just because those currencies are, you can get a lot of those currencies for the US dollar. I mean, nominally, those currencies are weaker. So the point is that the differences you see here are not for important reasons, but nevertheless, there are significant differences which we need to allow for if we want to do a proper test of purchasing power parity. And again, we're looking at this coefficient here, and we want to know if it's 1. Well, again, it's not 1, because look at the confidence interval. Confidence interval does not include 1. And again, we can do a test, which is an F-test. If you use the test command, you get an F-test statistic, and we're testing one restriction, and we get an F-test statistic of 41, which is strong rejection. We're rejecting purchasing power parity strongly. Okay, what's next in the do file? Well, the point that I want to make here, one of the reasons why I'm showing you this, what happens when you add all these country dummies, which you're not really interested in, but you still need to add them, that's a panel data model. And that's what we call the fixed effects model. So when you see fixed effects, when you're reading and you see someone's used fixed effects, this is what they mean. They just mean they've done a regression with lots of dummy variables for the countries or for the firms or for the households, whatever it is, the cross-section dimension. So you can do this, which is you can do the XT set. We've already done XT set, but we can do it again. We're declaring the data as panel data. and then we're using the xtreg command. Xtreg means panel data regression, and the option here is fixed effects. FE for fixed effects. And this, if we run this command, we'll get the same result as what we've just got. What we've just got is, the thing we're interested in is that number there, 0.9079. We're not interested in all these, so we don't want to see those. But when we do xtreg with FE, we don't see all the country dummies because we're not interested in them. However, they're all there. We do see the things we are interested in, mainly the 0.9079 and the confidence interval. Notice what we've got up here. This is xtreg fixed effects. Number of observations 464. It also tells us the number of groups. Number of groups is the number of countries. Observations per group, that's the number of years. Observations per group is number of years. Well, that's usually, well, it's sometimes 11. It's usually 11, isn't it? But sometimes it's not 11, and that's because some of these countries have not always been in the index. You'll find that some of the countries, maybe because they didn't have McDonald's until 2015 or something like that. Some countries don't appear in every year. So observations per group is between 7 and 11. And it looks a bit like the regression table, doesn't it? Because we've got the thing we're most interested in, which is here, standard error, t-ratio, etc. Now, notice that we've got another section of the table. This is because it's a panel data model. Sigma U in a panel data model is a measure of the between country variance. See, there's two types of variance in a panel data model. If you like, there are two variance components. There's between country variation, which is the 0.32, and there is the within country variation, which is 0.19. So you can see that the between country variation is more important. So it's important to use a panel data model, because if you don't use a panel data model, if you do what we did before without the dummy variables, then you're assuming that there are no differences between countries, and that's a false assumption. Notice there's also an F-test here. F-test that all the U's are 0. The U's, the UI's, are think of them as the coefficients of the country dummies. And if they're all 0, that means that there are no differences between countries. So that's what we're testing here. We're testing the joint significance of the country dummies, and we've got a F statistic there and a p-value here. All that's saying is that there are major differences between countries which need to be accounted for. So using this approach with fixed effects is the right thing to do. And of course, we can test for purchasing power parity yet again. Having done the fixed effects model, having used this command, xtreg with fixed effects, we can test for purchasing power parity. Again, we're testing slope equals 1. Again, we're rejecting. It seems like we're rejecting every time, but this is a normal thing. And there's another panel data command which you should know about. If you use panel data models, which some of you will next summer when you do your dissertations, some of you will find yourselves working with panel data. And I hope you understand what I've just told you, which is one way of doing it is just to use dummy variables for the countries. And that's the fixed effects model. The other model is the random effects model. And that's when we have the RE option at the end instead of the FE option for fixed effects. We have RE for random effects. Now, random effects is different because fixed effects the one we've just done, uses dummy variables for each country, and think of it like you're estimating an intercept for each country. You're estimating a different intercept for each country, so you're estimating 43 intercepts. Random effects does not do that. It doesn't estimate all these intercepts. All it does is it says, we know that these intercepts vary. Why don't we just try to estimate the variance of these intercepts? One parameter instead of 43. We're not interested in what these intercepts actually are, but we need to allow for the fact that they're all different. So why don't we just try to estimate one parameter, the variance of the intercepts? That's what random effects is doing. Now, it's a much better way of doing it because you're only estimating one parameter instead of 43, but there are assumptions which need to hold in order to be able to use random effects. Let's just see what happens when we do it. This, sorry, that was lines 68 and 69 of the do file. XTReg, our model with RE as the option. Again, we've got 43 groups and 10.7 years on average. And again, we have an estimate of the slope. This is the thing we're interested in. Is it 1? It looks like it's not. Again, we have 2 variance components. And this is the random effects model. And I stress, this is a better model, because to get this model, we have not estimated lots and lots of different intercepts, which is inefficient. All we've done is we've estimated one parameter for all the intercepts, which is sigma u, which is like the standard deviation of the intercepts. How much do they vary? Now, which of these models is correct? We've got random effects and fixed effects. I'm telling you, it's much better to use random effects, but you need to test whether, you need to do a test of whether random effects meets the required assumptions. And the test that we do here is the Houseman test. And that test is here. Notice that after we've estimated the fixed effects models, we store the results as FE, store FE. This is on your Stata command sheet. Having done the random effects model, we store the results as RE, and then you do the Houseman test, which is based on the 2 sets of results. Basically, the Houseman test compares the 2 estimates. See, we've got an estimate from fixed effects, which is 0.907, and an estimate from random effects, which is 0.925. Essentially, you're testing the difference between those 2. If that difference is very large, then you need to use fixed effects. If that difference is small enough, then you can use random effects. So we're testing this. Is there a significant difference between those 2 estimates? Well, yes, there is. There's our test statistics, chi-squared 1. There's our p-value. We are finding evidence of a difference. So yes, we should use fixed effects, but notice it's not strong evidence. The p-value is 0.03. The p-value is not 0.01 or lower. So it's not, we're not strongly rejecting random effects. We are just rejecting random effects in favor of fixed effects. Okay, now this is a bit off the beaten track. This is not actually part of the syllabus of the module you're taking now. What I've just shown you, the panel data models, fixed effects, random effects, and the Houseman test. The reason I'm telling you this is because I'm telling you that a lot of you will need this technique when you do your dissertation. Right, there's one more thing to do, one more part of the exercise. Let's go back to the exercise. We've got to here. Finally, consider this model. Same as before, dependent variable, same as before, it's price ratio, intercept, slope, log exchange rate, plus, now we're adding a new explanatory variable to the model, which is GDP. in the country. Now, this is obviously GDP per head, because GDP in a big country is bound to be bigger than GDP in a small country. So it's GDP per head. And the first thing we've done, well, the data that we have in the data set is GDP in dollars, GDP in US dollars per head in each country. Let's look at the data. It doesn't seem to be available everywhere. There are some missing values, aren't there? This is GDP in dollars. Argentina, $9,000 in 2011, lower, $8,000 in 2021. Australia, $55,000 in 2011. Oh, of course, it's lower in 2021 because of COVID, right? So if you look at Australia, 55,000, gradual growth, 66, 67, oh, down, 61. Not sure if this really makes sense, but no, this is valid data. Brazil, 10,000. Britain, 36,000. Gradual increase, and then 2018 fell. Why was that? Anyway, this is GDP in dollars, in US dollars, GDP per head. And the next variable is GDP in the UA in the same year. So if we take the ratio of these two things, then we've got like a GDP ratio. It shows us how well off the country is in that year relative to the USA. And if it's less than 1, then the country's worse off than the USA. And if it's more than 1, the country's better off than the USA. And that's the variable we're using here. And we're taking the log of that variable. And we basically, we're finding that prices differ between countries. The question we're asking here is, why do prices differ between countries? Well, one obvious reason is prices are higher in countries with higher GDP. So that's what we're testing here. And we're going to do a one-tailed test on beta 3. See, one-tailed because we have a prior belief that countries with higher GDP have higher prices. So if beta 3 is positive, that tells us exactly that. High GDP means high prices. And this is the Balassa-Samuelson effect. And this is one reason for the failure of the law of one price. If we're saying that countries with high GDP have higher prices, then we're saying that prices aren't the same in all countries. Let's test this. We're generating a GDP ratio. We're on page 7, we're on line 77 of the do file. GDP ratio is GDP in dollars divided by GDP in USA. Then we're taking the log of that ratio, and that's our explanatory variable which we use. And let's use the fixed effects model because we've decided that the fixed effects model is the best model. And then let's test for PPP again. Okay, so it's a fixed effects model. That is, it's a model with lots of dummy variables per country, but the coefficients for the countries are not shown. This is again, the coefficient of interest. It's way down, it's 0.6. It's a long way from 1 now. GDP ratio has a positive effect, which is significant, strongly significant. So that's strong evidence of the Balassa-Samuelson effect. Countries with high GDP have high prices. And this is one reason for the breakdown of the law of one price. Now, why? Why do countries with high GDP have higher prices? Well, two main reasons. One, because consumers in a country with high GDP, consumers are better off, so consumers have a higher willingness to pay. If consumers have a higher willingness to pay, price goes up. Another reason, costs of production are higher in countries with higher GDP. Costs of labor, for example, McDonald's have to hire local labor. In a country with high GDP, they have to pay more to staff than in a country with low GDP. So that's another reason why we expect the price of a Big Mac to be higher in a developed, and the price of all goods, for the same reason, to be higher in a developed country than in a developing country. So those are the reasons for the Balassa-Samuelson effect, which is the positive coefficient here. Notice that by controlling for that effect, we are getting a more pure test of purchasing power parity. I mean, we can still test for purchasing power parity. What we're asking here is, if every country in the world had the same GDP, would they have the same prices? No, they wouldn't, because this coefficient is nowhere near 1. And the test for PPP is here. There's the test statistic, there's the p-value. We've got a strong rejection of purchasing power parity. So every time we do this, we're rejecting PPP. As I said earlier, there's no point in testing the law of one price, because if we reject PPP, we will inevitably reject law of one price as well, because PPP is weaker. It's a weaker restriction than the law of one price. So, I mean, this data that we've been using, it gives us disappointing results from the point of view of the theory. I mean, really, we want the theory to work, but it doesn't seem to work on the data. It doesn't work very well, although, you know, this number looks a long way from 1, doesn't it? The numbers we were getting earlier were much closer to 1. They were numbers like 0.92 and 0.95. The interpretation of that number that's close to 1 is just, yes, the exchange rate is adjusting when prices change, but it's not adjusting as much as it should. So it's adjusting by 90% of what it should. That's roughly the interpretation. Any questions? We've got to the end of the exercise on exchange rates, and I'll see if there are any questions from outside. Yeah, I mean, if you go back to the lecture notes, what I did in the lecture notes, this is the lecture on Monday. I gave you some exchange rate data. Then I showed you a graph of the pound sterling against the US dollar, or this is the number of US dollars you can get for £1 sterling. This is 10 years of data, and I told you that the short-term influences on exchange rates are things like elections and referendums. 2016, we had the Brexit referendum, and look what happened to sterling. In 2020, we had the onset of COVID, and again, sterling took a dive then. But I explained that COVID affected every country in the world, but you can't have every exchange rate falling on the same day. If some exchange rates fall, then other exchange rates have to rise. Think of that. But those are the short-term influences. Other short-term influences are macroeconomic policy and financial factors. In the long run influences of exchange rates are what we've been talking about today, which are the law of one price and purchasing power parity. And everything else that I've told you in the lecture on Monday are the same as what we've done today. So if you want the answer to what we've done today, you'll find it here in the lecture. There's the original data set. There's the sorted data, 2021 data set sorted by the price of the Big Mac. And then we talk about this model, and then we estimate the model in various ways. Pooled regression, and then fixed effects. Oh, yes, this is fixed effects because it has the country dummies, and then we use the fixed effects command, get the same result. And then I've got some notes here about panel data models. And then I didn't talk about, in the lectures, I didn't talk about the random effects model. So what I told you today about the random effects model and the Houseman test, that was in the workshop, but not in the lecture. And then I gave you the results for the Balassa-Samuelson effect, and I've explained why the Balassa-Samuelson effect is expected. And at the end of the lecture, I told you to look at this paper, which I put on the Blackboard site, which is a sort of survey of what has come to be known as Burgernomics, studying the Big Mac index. Any questions? Yes, the exam is 24 hours. The exam is in January. You'll have a practice exam. Okay, we've got a QR code. Thanks, Joel. Now, Joel, is this the QR code for which module is this the QR code? Is it the QR code for econometric methods? Yeah, econometric methods. Okay, well, look, why don't you just all click on this, and then at least you can say you've attended the workshop for econometric methods, even if you're not doing econometric methods. Okay. Any other questions? Yeah, someone asked if the exam is 24 hours. Yes, you've got an exam in January, a computer exam, which is indeed 24 hours. You've got a practice exam in week 12. And week 12, at a certain time of the week, you will have a practice exam, and we'll give you 2 hours to do that, but we'll give you the answer to it, and you can take it home and carry on working on it. Any other questions? Okay, I'll see some of you next week. Now, remember that your timetable's changing big time next week. So please know what you're doing next week. We hope the timetable's correct. Some of you have got a lecture at 9 o'clock on Monday morning. If you're doing financial econometrics or financial econometric theory, I think you've got a lecture at 9 o'clock on Monday. Who's doing financial econometric theory? Ah, good. Financial econometrics? No, who's doing financial econometric theory? No one. Oh, wait a minute. Anyone online? Okay, sorry. Yeah, there are people online. Thanks. I'm pleased to see some of you here. But there's no one in the room who's from financial econometric theory. All right. Oh, well, it's good to see some of you here online. And yes, I believe you've got a lecture on at 9 o'clock on Monday. If you're financial econometrics or financial econometric theory, correct me if I'm wrong. If you're banking econometrics, I think your lecture's on Thursday, and then your workshop's on Friday in this slot, in this room. Won't be very full. And then if you're doing econometric methods, what? Yeah, I'm just trying to think when your lecture is. Do you know when it is next week? I think I think your lecture's 9 o'clock on Monday morning, if you're econometric methods. Yeah, Joel Clovis is giving the lecture for econometric methods, and it's 9 till 11 on Monday morning. Okay, that's econometric methods. And then the workshop is sometime later in the week. Now, someone's just asked me if there are 2 sessions on Thursday. What sessions of what?
Hi, hello.
Hello.
According to my timetable, it shows that there are two sections because I do banking econometric.
Okay, banking econometrics. I think your lecture is on Thursday of next week, and your workshop is on Friday of next week in here. So I think it sounds like your timetable is correct. And the lecture next Thursday is a 2-hour lecture. Does that make sense?
But on my timetable on Thursday, there are two sections. One is at 12, 12:30, and another one is at 4 o'clock.
Really? I'll have to look into that. I'll definitely give you an answer before next Thursday. Okay, sorry about that. That's confusing.
Thank you very much.
It's all right. No, for financial econometric theory, the lecture is on Monday, but the workshop is, I think, on Wednesday. But look, your timetables, I expect your timetables all to change sometime over the weekend. They'll be updated. Obviously, I'll send you all emails by the Blackboard sites. Okay, so I'll tell you what's going on, whatever happens. All right. I'll see some of you next week.